In the last two examples, we looked at some linear equations, rewrote them using function notation, and then interpreted the slope, just reading that from the equation. Now what we want to do is look at how we can go about calculating the slope if we're not given the equation or given the function for our line. In example 3, we're given the graph of a function p. We want to find its slope. In order to do that, we just need to find any two nice coordinate pairs. We can do it with any coordinate pairs. It's just easier when we have a nice pair. So for instance, if we looked at the point 1, 2 and 2, -2, then we can use the slope equation where we take the difference of our y values, so -2 minus 2, divided by the difference of our x values, 2 minus 1, to get -4 over 1, or -4. As a quick check, we can see that in this case, our slope is less than 0, which makes sense because the line that we were looking at was decreasing as we read it from left to right. It doesn't tell us that -4 is right, but at least lets us know we're on the right track. In example 4, we want to repeat this same process, but we're given different information. Now what we have is the assumption that a line passes through g of -4, -33, and g of -3 equals -23. We want to find the slope of this function g. This is actually the very, very similar. Our approach is going to be very similar. And to help understand this information that we're given in function notation, we can look back at the 2 points that we found in example 3 and notice that if our first coordinate pair is 1, 2, that's the same thing as evaluating this function p at x equals 1, and when we do that we get a y value or a function value of 2. Similarly, the coordinate pair 2, -2 tells us that our function p evaluated at x equals 2 gives us a y value or a function value of -2. That means we can translate this function notation information that we have in example 4 to give us two coordinate pairs. X is -4 and y is -33. And for the second pair we have x is -3, y is -23. So the coordinate pairs, the function notation, they mean the same thing, just represented in different ways. And then again, we can use the slope formula by taking -33 minus -23 all over -4 minus -3. Being sure to be careful with those double negatives. This is the same thing as -33 plus 23 all over -4 plus 3, or -10 over -1. The two negatives cancel, giving us a value of 10. We're not looking at the graph of this line, but we can see that our slope is our slope is greater than 0, so our function would be increasing in this case.